Before we look at any more problems, it's worth noting that the graph of an inverse function can be obtained from the original graph by reflecting it over the line y is equal to x. For example, in the last video, we saw that y is equal to 5x cubed plus 1 has an inverse given by y is equal to the cubed root of 3. Oops, I meant the cubed root of x minus 1 divided by 5. And the graph of f in this case was given by the following picture. So to find the graph of f inverse, we'll go ahead and draw a line y is equal to x. And we'll draw a mirror graph of our f of x across the green line. So this portion of the graph will be reflected to this piece over here. And this portion of our graph will be reflected like so. And this would be a graph of our f inverse. Now let's go ahead and look at a few more problems. In this case, we want to restrict the domain so that our function is 1 to 1, and then find an inverse of the function f of x, which is equal to the square root of 2x plus 3. Let's go ahead and sketch a graph to see where our domain is going to be 1 to 1. So the general shape of the square root function looks something like this, and we know the square root is already 1 to 1, but this square root function is shifted over to the left by 3 units. So the domain we want to restrict to is we want all x values that satisfy the following inequality, which is 2x plus 3 is greater than or equal to 0. Solving this, we get x must be greater than or equal to a negative 3 divided by 2. Writing this in interval notation, the domain of our function is going to be negative 3 divided by 2 to positive infinity. We can also go ahead and state the range. This is going to be all y values between 0 and infinity. So now we can find the inverse. Let's rewrite our function real fast. We'll get y is equal to the square root of 2x plus 3. Now switch your x and y. We'll get x is equal to the square root of 2y plus 3. Square both sides and we get x squared is equal to 2y plus 3. And now, again, we're just solving for y, which means we'll get an x squared minus 3 divided by 2 is equal to y. And this is our inverse. And since we're already here, let's go ahead and graph the inverse of f of x. So go ahead and draw the line y is equal to x. And what we see, again, is that the domain of f of x is going to be the range of f inverse, and the range is going to be the domain of f inverse. So reflecting our function f of x over the line, what we'll see is that our function of our inverse should look something like this. Now let's go ahead and look at finding the inverse of a rational function. So in this problem, we're trying to find the inverse of the rational function f of x is equal to x plus 3 divided by x minus 2. Again, we should start with just finding the domain. So the domain is going to be all numbers where the denominator is not equal to 0. So the only place where we have the denominator equal to 0 is when x is equal to 2. So let's just go ahead and find this set. This is going to be all numbers but 2, which means we're going to be looking at negative infinity all the way up to 2, and then 2 to infinity, again not including 2. And we can write this in interval notation as negative infinity to 2, union 2 to infinity. Now let's find the inverse. We'll rewrite our function. Y is equal to x plus 3 divided by x minus 2. Switch the x and y's, and we'll get x is equal to a y plus 3 divided by y minus 2. And then we need to go ahead and solve for y. So multiply both sides by y minus 2. and we'll get x times y minus 2 is equal to a y plus 3. Multiply our x across, and we'll get xy minus 2x is equal to y plus 3. Subtract xy on both sides and subtract the 3 on both sides. We'll get a negative 2x minus 3 is equal to a y minus xy. Let's go ahead and start a new page. Now what we can do here is pull a y out on the right hand side, and this gives us negative 2x minus 3 is equal to y times 1 minus x, and so now we can divide both sides by 1 minus x. This gives us y is equal to negative 2x minus 3 divided by 1 minus x, and this is our inverse function.